Okay, this lesson is on similarity of triangles, term 3, lesson 2. Okay. All right, here we have a triangle that has 3 angles in it, A, B, and C. And let's remember the theorem that all 3 angles add up to be 180. Okay, all 3 angles. Okay, we have these 2 vocabulary words, congruence and similarity. Congruence, this is the symbol for congruence. It says in geometry, 2 figures or objects are congruent if they have the same shape and size, or if one has the same shape and size as a mirror image to the other. On the other hand, similarity is 2 polygons that are similar when one is a replica or of the other. Think of a scale model. So one could be smaller, one could be larger, but they are similar because their angles are the same and their sides are proportional. All right, you guys have a worksheet in front of you, like for notes, and you'll want to fill these in. So the definition of congruence versus similar, okay, versus similarity. And on that, this column right here, this column will be for congruent figures. And this column is for similar. Okay, notice the definition for congruent figures. They have the same shape and size. Similar figures have the same shape, but usually have different sizes. And maybe you want to put on this, though, that the angles are equal, okay? They have the same measurement. So now down here in your diagram right here, if you would, come down here and draw 2 figures that are congruent. That means they have to be the same shape and the same size. Notice this is A, this is A prime, okay? Notice this is B prime, C prime. Okay, but notice over here on similar, we have the same shape, okay? But they are not their sides are not the same length. Okay, the symbol for congruent is this little squiggy with an equal sign underneath that. Think of that. And for similar, it's just a little squiggy. Okay. All right. Here we have how are these figures formed? Okay. So congruent, once again, this is your congruent column. Okay. This is your similar. Okay, so congruent figures are formed by rigid motions, reflections, rotations, and translations. Similar are dilations or rigid motion, reflections, rotation, translations. Okay, angle relationship. Corresponding angles are congruent. Okay, corresponding angles are congruent. Remember, in both of these, the angles have the same measurement. However, on the side relationship, we have corresponding sides are congruent, which means they measure the same measurement, but these sides are proportioned, meaning that they have to have equal ratios, okay, on the sides, and we'll talk a little bit about that, okay? All right. Okay, consider Dr. Evil and Mini-Me from the Mike Powers hit movie Austin Powers. Mini-Me is supposed to be an exact replica of Dr. Evil, but are they congruent or are they proportional? Okay, that's what you have to kind of think about. Okay, this is a dilation. We have a smaller one and we have a larger one. Same shape, okay, but one is just larger than the other, so they're replicas. So I shouldn't say replicas, they're a dilation, okay? So this is your pre-image, this is your new image, so they're similar. Okay, here we have similar figures. One is smaller, one is larger, same shape, same angle, same everything, but the sides are not the same length. Same thing in this picture, okay? Then we have some more pictures of non-similar figures. Okay, which of the following is a similar, let's see, which of the following is similar to the above triangle? Okay, so what would you pick there? Okay, which one is similar? Well, if you know what similarity means, I hope that you would pick A. Okay, similar triangles are triangles that have the same shape but not necessarily the same size. Notice we have this triangle ABC, and then we've got DEF. Same shape, looks like the same angle measurements because they are the same shape, but they're definitely not the same size. Okay, but they are similar. When you say that triangles are similar, there are several repercussions that come from it. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F, which means they have equal measurement. They're congruent. However, the sides, okay, are proportional. So AB is proportional to DE, okay? And then BC is proportional to BCEF. And then AC is proportional to DF, okay? So we have these statements that we go off of to determine if something is similar. Okay, the first theorem is the similarity theorem. It is side, side, side. That means that the three pairs of proportional sides have the same ratio. Okay, so proportional sides means the same ratio. Okay, similarity, notice this is side, angle, side. Notice that the angle has to be between the two sides. So two pairs of proportional sides and congruent angles between them. Okay, this one means angle, angle. Because if two angles in a triangle are congruent, then we know the third must be also, because they have to add up to be 180. Okay, all right, so let's look at the first theorem, side, side, side. Three sides are proportional. Okay, we have two triangles here, okay? And we're going to check to see if their sides are proportional. Now, if it makes you happier and you can't relate to it being kind of this way, then turn it so F will be here, okay? And then this side will be E, or this angle will be E, and this one's D, so that you can compare the two sides, okay? If standing straight up works for you, great. Okay, here we go, 5 and 4. Okay, so DF is 4. So if it helps you on this triangle for me to turn it this way, you're comparing 5 to 4, okay? Let's see what kind of a ratio we get as we set those up. So measurement. This M right here, guys, means measurement. The measurement of side, this right here means segment. AB equals 5. The measurement of DF, segment DF, is 4. So I divide these two right here, and I get 1.25. All right, let's see if the other sides have the same ratio, 12 and 9.6. So just know on this triangle right here, this is 9.6. So you're comparing 12, 9.6, okay? All right, so let's see if they're proportional. So we have the measurement of BC and the measurement of FE. So we've got 12 divided by 9.6. Look at that. We get 1.25, guys. That's great. Okay, we got one more, so we've got two sides that are proportional. Let's see if the third one is. We can't assume that they're proportional. We have to check. Okay, so we have side AC is proportional to DE. And if it helps you on this triangle, this is 10.4. You're comparing this side to this side. Okay, so let's see what our proportion is, everybody. All right. Okay, let's look at it. We had 1.25. So because we got 1.25 3 times because we did this 3 sides of the triangle, that means that they are similar. So that's how you do the similarity theorem. Okay, let's look at side angle side. All right. Okay, so once again, if this messes you up, you can turn your triangle around a little bit to kind of help you with it. But if you can understand it the way they are, fantastic. All right, okay, here we go. Okay, we have 5, and it is going to compare to what side? LK. So let's look at our side. So we got measurement of GH is 5, measurement of LK is 7.5. You get 0.66. Okay, right here we have an angle, 70 degrees. Okay, they're both equal. That's good. Okay, so now let's compare another side of a triangle with its proportional side. So we've got 7, and we've got this one at 10.5. Let's see how they fare out. Oh, look at this. The measurement of HI, measurement of KJ right here, 10.5. 7 divided by 10.5 is what? 0.66. So that satisfies this theorem, side, angle, side, because our sides are proportional. Yay. Okay, so we have similar triangles. Notice the symbol right here, similar. Make sure you're using the right symbol. Right. And let me talk about this triangle here, GHI. Notice how they've written this. G, they start here. Maybe. Okay, here we go. G, then H is the angle, then I. You got to go in the same order. What went with G? LK, right? Then the angle, and then the side. So you need to put those in order as you write your answer. Okay, side angle side theorem does not work unless the congruent angle falls between the proportional sides. Okay, so let's take a look at these two triangles again. Okay, those sides are those two sides right there, are the two sides that you would compare. However, if you put the angle not between the two sides, remember how our angle on the last problem was right here? Okay, this angle was created by GH and HI, but our angle's out here. Okay, if the angle does not fall between the two sides, then it does not satisfy side angle side. Okay, let's look at angle angle. Okay, this one makes a lot of sense because remember that your angles, angle 1 plus angle 2 plus angle 3, have to add up to be 180. So if you get two matching angles, then you know the third will match, also be the same or congruent. Okay, so if this is 70, R is 70. Okay, great. Okay, O is 50, P is 50. Fantastic. Okay, then we know that these two triangles are congruent. Okay, because if you add, so let's put this right here, 70 plus 50 plus some other measurement is 180. Okay, these two are 120. Subtract that from 180. You're going to get 60. Both of these angles up here would have to be what? 60 degrees, because there's 100. These angles have to add up to be 180 degrees. So two angles give you similarity. Okay. Now, is it possible for two triangles to be similar when they have two pairs of angles, but only one of those pairs are congruent? Let's check this out. So we've got a 34 and a 34. Okay, that's looking good. We've got a 59 and a 34, but this one says 87. They could be congruent, but this is where you've got to use your 180 theorem to find it out. So let's check it out. Okay, 34, they match. So those match, so that gives us one angle. So if we do 180 minus 34 plus 87, okay, let's see what we get here. Okay, which is 121, which is 59. That means this angle down here is 59. Oh, wonderful. Does that match an angle over here? Absolutely. So therefore, it is possible. You've just got to use your 180 theorem to determine that. Okay? All right. So therefore, we've got two angles. So there we go. Those are similar triangles. Okay, one triangle is the scale model of the other. So let's try and see what we get here on this one. Okay, so when you're saying a scale model, that means there's a possibility of similarity here. Okay, so how do we know if two triangles are similar or proportional? All right, so let's kind of look at this theorem here and see what we've got. So determine whether the pair of triangles is similar. Justify your answer. All right, well, you got to use your 180 theorem again, okay? So what you can do here is you can do, in this triangle right here, you could do 180 minus this angle, 42, minus the other angle, which is what? 42. And when you do that, guys, you're going to get 96. So this right here is 96. Right there is 96. So what do we know about this angle and this angle? Because these are congruent, they're the same measurement, you can do 180 minus 96. All right. Okay, that's going to give us 4. This is 17. This is 84. Okay, now I have to take this 84 and I have to divide it by 2 because I got to split it between the two angles. So right here, we went a little ahead of the game. Whoop, let me go back. This went a little ahead here. Thank you. All right. So 84 divided by 2 is going to give you what? Oh, goodness gracious. It just wants to do its own thing today. Okay. Anyway, this is going to give you 42. We'll stay right here. So that means this is 42 and this is 42. So therefore, these two, the corresponding angles are equal, so the triangles are similar. Okay, if the product of the extremes and extremes equals the product of the means, then a proportion exists. So we'll be talking about that. In other words, you can cross multiply and those should be equal. So BC should be equal to what? AD. And this allows for us to solve if we have a missing side. Okay, let's take a look at this. Okay, side AB, so if these are two proportional triangles, AB is proportional to XY. That means that they have a ratio value K. All right, that means 12 divided by 6. Notice right here, we're going to take 12, we're going to divide it by 6, and set it equal. They are 2. Okay, let's try two other sides. Okay, BC. Okay, where's my BC at? Okay, right here. 8 is proportional to what? 4. Okay, so let's try that. 8 divided by 4 is 2. Notice what our ratio is giving us. 2 every time. All right, let's do it one more time. AC, so I'm just going to box this one up. AC is proportional to XZ. All right, 10 divided by 5 is 2. So what did I get? I got 2 every time. So that means that these two triangles, guys, are similar. Okay, they're proportional. Therefore, they're similar. Okay, can these be similar? Okay, yes, right triangles can also be similar. Okay, we're meaning right, meaning they can be similar also. Okay, and we proved that. Okay, all right, on this one. Okay, in fact, let me back this up. I think I skipped over something. Okay, so let's look at this. Let's back up here for just a minute. 6 over 4. Okay, super. There's 6 over 4. Then we've got 8 over what? 6. Great job. Now this one is 8 over 8 instead of 8. So let's check this out. 6 divided by 4, guys. What do you get? You get 1.5, I believe. Okay? All right. So 8 divided by 6 is also what? Do it in your calculator. Give it a shot. What do you get? Okay, this one is 1.3, I believe. 26, maybe repeating. And this one right here is going to be 1.25. Darn, are any of these the same? No. So therefore, these two particular triangles, guess what, guys, are not, they don't have the same scaling factor, so therefore they're different, so they're not similar, okay? All right. Okay, we've got two triangles below are known to be similar. Determine the missing value. Now, this is where we're going to have to use a little cross multiplication. Okay, we're going to have to set these up. And what you have to do is you can see the setup here in the screen, but how did they get it? Okay, let's go for a side on this triangle that we know. And what is its proportional side? 5. Okay, because it says they're known to be what? Similar. So they're telling you they are similar triangles. They're going to have, their sides are going to be proportional. So notice here, 7.5 and 5. All right? Okay, so we got that. Now, what side are we solving for? X. Okay, we don't really need to worry about 4 over here, but we do need X. What side is its side that is similar over on the other triangle? 4.5. So we're going to put 4.5 over X. All right? Okay, this is where we're going to do some cross multiplication. We're going to do 5 times 4.5. So let's write that here. 5 times 4.5. I'm going to put this in parentheses so we don't get these little decimals messed up. And 7.5 times X. All right. Okay, how do you solve for that? Divide by 7.5, divide this by 7.5. So X is, you should get a 3. So this side right here is a value of 3. Okay? Okay, we'll see how we do it. Cross multiply. There we go. We set it up, and there we have it, 3. All right. In the figure, the two triangles are similar. Okay? They're similar. So that means that they're proportional. So that means I can do a little cross multiplication. Okay? All right. Notice here that this angle here is congruent to this angle here. That means they're the same measurement. And this angle is the same measurement. So C is going to go with what? 4. Okay? All right. So let's put C divided by 4. In fact, let me erase this. But then let's find two sides. We're going to have C and 4 here in just a minute. Okay? All right. Okay, now let's find two sides that I know for sure. How about 10? 10, and its matching side over here is a 5. So let's go ahead and set that up. Okay, 10 divided by 5. Notice that this is the big triangle. This is the small triangle. You've got to keep your sides together, 10 and C on the small 5 and 4. Okay? All right. Okay, what we're going to do is we're going to cross multiply 5 times C. That gives us 5C. 10 times 4 is 40. Okay, how do we solve it from here? Divide by 5. Okay, and so you should get what? C is 8. So that means, guys, this side is now 8. All right? Okay. Now, let's do it again, because do we have any other missing sides? Oh, my word, we do. D, we got to find D. Okay? So let's do it again. Okay, pick two sides that you know. Okay? We're going to do 10 and 5 again. You can just use the same sides. And then what goes with D? 6. So we can choose 6. And the side that matches up with it on the smaller triangle is D. Okay, so there we go. Set up. Okay, then we're going to cross multiply. 6 times 5 is 30. 10 times D is 10D, right? Okay, then we're going to divide by 10. And so what are we going to get? D is 3, because these are going to reduce. Okay, fantastic. All right, now, sometimes we have a situation where we are going to, here's a triangle right here within a triangle. So we have our smaller triangle. Its sides are 6 and 17. And then we have this great big triangle here. Whoop, that's not very good. Okay, so let's get rid of that. But anyway, we've got this big triangle here. Okay, the larger one on the outside. Its long side here is 102, and we want to find out how tall that tree is. Okay, so let's go ahead and set this up. Okay, now notice 17 and 6. 17, 6 is the small triangle. This is the large triangle, the tree. So we've got 17 on the bottom, okay, and his height is 6. So 17 and 6. Okay, what's the height on the bottom for the tree? 102. It's from this point. From this point, it's 102 feet, I would assume. And what's its height? We don't know. Okay, once again, cross multiply. Okay, and then you're going to get, when you do that, when you do 102 times 6, you're going to get 612 equals 17h. How do you solve for that? Times by h, or no, excuse me. Okay, 17h, divide by 17, excuse me, and then you'll get 36, okay? Let me erase this right here and get an h there, okay? Okay, we had a 17h, so you have to divide by 17. Okay, good deal. Okay, two triangles are called similar if their corresponding angles have the same measurement. Notice this, A and A, B and B. Okay, we can just call that, I don't know what that is. We'll call it C. All right, C and C. All right, so we've got, here we go, and their sides are, so we've got angle A, side, or excuse me, let's see, little a, their sides, little a, big A, right here. Sides are proportional. Little b, big B, sides are proportional. Okay, little c, big C, sides are what? Proportional. Okay? Okay. Okay, congruent figures. In order to be congruent, they have to be the same shape, and their angles have to be the same measurement too, okay? Notice that these are similar figures. Notice the difference. Congruent is the exact replica. These ones are dilations, where one is smaller, one is larger. Okay, this one, although the size of the two shapes can be different, the sizes of the two shapes must be differed by a factor, okay? You've got to have a factor in order to be able to do those. So a factor of what? And how do you figure that out? Okay, notice right here, we're going from 2 to what? 4. So this one, the larger one, is twice as big. We've got a 3 and a what? 6. We've got a 3. 3 times what is 6? 2. 1 times what is 2? 2. So now notice that this factor, this from the smallest figure to the largest, has been, the largest is 2 times larger than the smaller figure, okay? But sometimes we can go, in fact, let me point this out. When you're going from the smallest to the what? Large one, you multiply. Notice we've got multiplication here. Okay, now let's take a look at this one. Now we're going the other way. We're going to go from 4 down to 2. So what do I have to divide 4 by to get to 2? You got to divide this by what? 2. Notice that this is the factor. We're dividing. You're going to go from 6 to what? 3. So you got to divide 6 by 3, or 6 by 2 to get to 3. Then we got to divide this 6 by 2 to get to 3, and so on. Okay? Sometimes we have where the smaller one, notice this is small, you're going to what? Large. So you're going to have to what? Multiply by, this one is 3 times bigger. Okay? Notice this one, we're going from the larger down to the what? Smaller picture. So we have to do what? We have to divide. Okay? All right, let's look at these. Determine the lengths of the unknown side. Okay, we have similar figures. It tells us they're similar, so their sides will be proportional. Okay, so what we can do here is we can say, let's see if they have a given here. Okay, we can just look and see if we've got a factor. Notice we're going from 9 to 3. Okay, we're going down. So what do you have to divide 9 by? 3. Okay, so if you can do it this way, this is a lot quicker. 12 to 4, how did I get from 12 to 4? Divide by what? 3. So what can I do with 15? Well, the other sides were divisible by 3, so let's divide this. So we should get a 5, okay? And that's what it's showing in here, that this side is actually what? 5, and we determined that on the other page. All right, let's take a look at this one, okay? How do we get from 2? Okay, let's look. We've got 4 to 24, and these are similar, so they need to be proportional, right? So we're looking at this, and if it helps you, you can set it up as a proportion. You have 4 to 2, 4 here, and now I've got 2 here, but now this is going to be 24 over what? X. We don't know. So guess what we can do? Because this one, we don't have enough to get a factor. So we're actually going to maybe have to do a little work here. 2 times 24 is what? 48 equals 4 times x, right? So divide by 4, divide by 4. What do you, oh, not 14. How about a 4? X is going to give us what? 12. Let's see if that's what we get. Yep, looks like it. Okay, so did you see this right up here? There's our 12 right there. Okay, all right, maybe we can try this one. I don't know on this one. What do you guys think? Okay, let's take a look at it. I don't know. This one says we've got 12, we've got an 18. But is it easy for me to get from 18 to 12? I don't think so. But what we can do is we can set it up to see what we have for proportion. So we can just do 18, or I'm going to go from, looks like it says from the largest to the smallest. So 18 divided by 12. All right. And then how about 12 and 8? Let's try that. And then we have 15 and 10. All right. If you have your calculator, I believe that this is going to be 1.5. You guys can figure that out. 12 divided by 8, you're going to get 1.5 right here. And 15 divided by this will give you 1.5. So it's looking that these are truly similar. This is what we call, because these are all 1.5, this is going to be, these right here, this is the scale factor. Now, notice we went down. So we have got to divide by what number? 1.5. This is what we have to divide by in order to get from 18 to 12. because we're going from the larger to the what? Smaller. That means what? Divide. Okay? And there's our answer right there, guys. Okay? All right. Okay. So let's look at this one right here. All right? Okay, we have two figures here. Here, when changing the size of the figure, will the angles change in the figure? What do we know about similar figures? No, the angles are not going to change. Okay? They are going to be the same degree. It doesn't matter. Just because you're creating longer sides does not mean that the angle value changes. We have to keep the angle value the same, or guess what? We're not going to have the same shape. Okay? So we can verify this by placing the smaller triangle inside the larger triangle, and you will see that the angle measurements are the same. So let's do that. Let's check it out. Does that work? Yes, it certainly does. Okay? The 40-degree angles are congruent. Okay? And also, the 70-degree angles are congruent. Okay? So that means that all the angles are the same measurement. It's just the sides that they change. Okay? All right. Okay, now we have a triangle inside another triangle here. All right. That means that they both have a 90-degree angle, right? That means that this angle is congruent to this angle. And that means that this angle is congruent to this angle. Okay? And if that's true, we have angle, angle, so we know that these two triangles are similar. However, we've got to do a little work here. So, let's do, so we have this long side here is 30. Okay? The short side is 6. So let's do large and small triangle. Okay? All right. The large one is 30. The small one is 6. Okay, now on this side, I've got what? 50 on the large one. But what is the hypotenuse on this triangle right here? I don't know. X. Okay? So we're going to have to do a little work here. 6 times 50 right here is 300. Equals what? 30 times X. Divide by 30. Divide by 30. What do we get? X is what? 10. So the hypotenuse here is 10. Okay? Or, I guess, we could have done the common factor. I didn't do the common factor, but look at this. 30 is to 6, so 30 divided by 6 is what? 5. That would have been quicker, right? And 50 divided by 5 would have given us what? 10. Oh, who knew? That would have been a lot quicker. So, look for factors, okay? Okay. However, I did show you how to do it if you weren't sure on the factors, okay? Okay. Suppose you wanted to know the height of this tree, okay? Just thinking about it. Unfortunately, all you have is a tape measure, and you're too short to reach the top of the tree. Sounds familiar for me, okay? All right, so here we go. So you take a tape measure, and you're going to go 10 feet out, all right? Okay. So, and then this is 2 feet between you and this distance, okay? All right. So what we're going to do here is we're going to try to find the height of this tree. So we know that we're 6 feet tall, and we're trying to find its missing side, how tall the tree is. I don't know. So let's go back here for a minute. We have 6, and on this triangle, okay, will be X. We have 2 to 10, right? Okay, let's see how we set that up, okay? Let's go back here. I went too far forward, guys. All right, my apologies. Lost my mind there for a minute. All right. Okay, let's do 6 over x equals 2 over 10. Cross multiply. What is 6 times 10? 60 equals 2 over x. Divide by 2, divide by 2. So x is 30. So this tree is what? 30 feet tall, which it tells me right there. Okay? All right, so we did a good job. Similar figures work just like equivalent fractions. So let's take a look at these. You can divide by 6, okay, and reduce it to 5/11ths, okay? Or you can see that their sides are similar by the scale factor that you can divide by. Okay, similar figures are two figures that are the same shape whose sides are proportional. Okay, we've kind of worked on that. So these 6 statements, or the 6 statements earlier, led us to this. Statement 1, okay? Side, side, side. Statement 2, side, angle, side. Statement 3, angle, angle, okay? Okay, how do you write a similarity statement? I kind of talked about that earlier a little bit, okay? So if you have angle A, what does angle A match up with? D. So we're doing triangles. So it'll be A. What matches up with A over here? D. Okay. C. What matches up with C? F. So in fact, let's see how they've got A, B. So they went this way. They went A to B. So let's do B. What does B match up with? E. Okay. So we'll have E. And then we'll go to C. Okay. And then we'll go to what? F. And then we say similar. Now, another way you could have written this is A, triangle A, C, B is similar to triangle. Now, notice if I go A, C, and over to B, I've got to do the same thing. D, and let's get rid of this. No. Let's get rid of this. We needed a triangle, and I wrote an A. Okay, triangle, D, F, E. This is also correct. So either one of these statements here would work for a similarity statement. Okay? Okay. Okay, this is practice time. Let's see what you guys know here. Okay, determine the missing side of the triangle. Okay, we have our small triangle over our large. That's how I like to write it. Your teacher may want you to do something just a little different on that, okay? But this is kind of how I do it. All right, okay, so we're going to write a proportion here. Okay, pick a side that you know for sure, okay? I'm going to go with 3, and I'm going to go with 9, okay? Now, we can do it this way, or we can do it a quick way and find this answer. Let's just test them both out. 3 times what is going to get you to 9? 3, right? So you might be timesing by 3. Let's check this out. 4 times what is going to get you to 12? 3 again. So 5 times 3, I could use that and get what? 15 over here. So you could figure it out by that, or you could do 3, the side 3 here is proportional to 9 on the large, and 5, I know, but its side I'm trying to find that matches up with it is x. So we have 3 times x, guys, which is what? 3x. And we have 9 times 5, which is what? 45. Divide by 3, divide by 3, so x is 15. You get the same answer either way, okay? Always try to use the quick way. All right, let's see if we can do this one the fast way. 6 times what gets me to 36? Okay, times by 6. 6 times what gets me to 36? Again, 6 to 36. So we're timesing by 3. So what is 4 times 6? Because I multiplied by 6 both those times, I can also do here 4 times 6 is what, guys? 24. That's an easy way to find a missing side. There it is. Okay? All right. Okay, let's try this one. Let's see. Oh, I don't know. 24. Now we're going from larger to small, right? So I've got 24 divided by what? 3 gives me 8. That looks pretty good. But notice here I've got 2 sides that are missing. I might want to do a little bit more work. So let's do the large to the small. Okay, what side do I know on the large? 24 over small is 18. Now, which side am I trying to find? I'm going to call this X. I'm going to call this Y. So let's find X first. It's on the small triangle, but what side goes with it? 33. Okay. All right, might have to do a little math here, get my calculator out. 24 times X is 24X. And then pop this in your calculator. 33 times 8, 24, 24, 25, 26, 264, 264. And then divide by 24, divide by 24. And guys, pop that in. Tell me what you get. All right. You should get, on this particular one, you should get 11, I'm thinking. Okay. So try that. Yep, should get 11. This one's 11. Okay, now to get the Y, now think about this, 24 divided by 3. Now let's check it out. 24 divided by 3 was 8. Is 33 divided by 3 11? Ooh, yay. So could I hurry and get this one? 39 divided by 3, what do we get? 13. So guess what? That worked. Saved the day. Knowing how to divide those and going from larger to smaller or smaller to larger by division and multiplication is great. Great way to save us there. Save us some time. We're all about saving time in math, I guarantee you. Okay, this one. Okay, this one you might have to do it a little bit. 2.5 times what gets me to 10? Okay, I'm guessing 4. All right, I'm guessing 4. And so if you can do that, 2.5 times 4, then you can try it here. 8 times 4 is what? 32. Or you could set it up. 2.5 on the smaller. 2.5 over 8 equals, okay, I should have put that 8, excuse me. Let's do an eraser. Let's do this. 2.5, because let's do small and large. So 2.5 with 8. And then we have 10 that goes with 2.5, and we're trying to find X. So when you do 10 times 8, you get 80 equals 2.5 times X is what? 2.5X. Divide by 2.5, divide by 2.5. You're going to get X is 32. So that's going to check out. Yay! So you can do it the quick way or the long way. I like quick. Let's try that. Okay, let's see what we've got on this. Okay, we got 5 to 12. 5 times what gets you to 12? Gosh, I don't know. So this one maybe not so smooth. So let's do small car on the top, large car on the bottom. All right. Okay, we're going to do 5 to 12. Okay, and then I know 3, and this we're going to call this X. Okay, so you're going to have to cross multiply. 12 times 3 equals 5 times X. divide by 5, divide this by 5, x equals, what's 36 divided by 5? I got 7.2. So that one didn't work out as nicely as the others, but hey, we still got the answer, okay? There it is, 7.2, okay? All right, now you're going to work with your teacher on this activity, okay? I am going to do the first problem with you and then show you where to go from there. So what we have here is this is on similar triangles. Once again, if they're similar, we know that their sides are proportional and their angles are equal. Okay, so we're going to do the large triangle here. I'm going to try and do it here on the side. We're going to do here at the start, the large divided by the small. Okay, so I've got 9, and its side that matches up with that is 6. Okay, in fact, let me just redo this again. Redo this. Okay, let's start this again. I may have set this up a little differently on my work, so let's do this. Okay, 9, I'm going to do the small triangle. I'll just put this right here. So we've got 9, maybe, 9, and x minus 2 on the small. Okay, on the large triangle, okay, the sides that match up are 6 and x minus 6. Okay, you're going to cross multiply, but when you cross multiply to solve, guys, you need to get parentheses around here. So you're going to have 6 times x minus 2 equals 9 times x minus 6. And you're going to solve for x. So this gives you 6x minus 12 equals 9x minus 54. Okay? All right, now the easiest thing to do is add 54 here and add 54 here. Oh, darn it. I hope that, there we go, add 54, and then minus 6 here and minus 6x here. Okay, so what you're going to get, darn, it just keeps going back. Okay, what we're going to end up with is we're going to end up with 3x here equals 42. Then you're going to divide by 3, and then you're going to get x is 14. Okay, now you're going to take that answer, guys, and notice the arrow here. You're going to go over here and put 14 in here, okay? And then you're going to go ahead and solve these two similar triangles, take that answer and put it in here, and then continue on the path till you get to the end. Thank you. Good luck.